morning, everybody. Welcome to today's lecture. I want to talk to you about virtual machines and the common language infrastructure. If you're doing C# programming, these are two topics that you need to be aware of. The material comes from my book, C# for Artists, 2nd edition, available at pulpfreepress.com. I'll give you a quick screenshot of the cover. There you go. In chapter 4, okay, and anyway, in the section Virtual Machines and the Common Language Infrastructure, starts off with the diagram, figure 4-14, the C# compile and execution process overview. So I'm going to start up here in the, where you see my halo and the C# source files. Okay, so you create a C# program. You know, depending on how you go about doing it, if you're just starting out, I recommend, you keep, and you're writing short programs, to satisfy short, targeted class projects. Then all you need is a text editor, okay, like Notepad++. I can bring that up. I'll let you take a look at what that looks like, right? These are, I feature these in a lot of my videos, just simple, typing in source code. And then compiling from the command line, so you can use the command prompt, right? And then in another video I have out there, I'll show you how to set environment variables so that your command prompt can find your CSE executable file. Or you can use PowerShell, okay? So there's a couple tools, right? Okay, so however, or if you're writing bigger projects, and there's a point where you get to your experience builds, and you're writing a bigger project with multiple source files, and multi-level architectures, that kind of stuff. Then you start getting up into the point where you don't need it per se, right? But using Visual Studio becomes a big help, right? If you don't know how to properly use Visual Studio and setting up projects, like, understanding what the solution is, understanding what sub-projects are, how to build DLLs and libraries, right? There's a lot of stuff going on to build a big project. And until you understand how the source compile process and execution process works, and until you focus on the fundamentals, and the fundamentals pay off when you go building bigger projects, right? And plus, it helps to have a person who does this stuff for a living that you can ask questions of, and they can show you all the neat tricks of the trade, right? But for these lectures, I just keep it kind of simple. And as the lectures progress, we will build more complicated projects and use Visual Studio. But in this lecture, right? Sorry about that tangent. I kind of want to focus on the basic process of building writing a short text file, source file, compiling it, and exactly what happens, right? I know I've put videos out there already, showing you how to do various stuff, and haven't really explained these fundamental concepts. Excuse me while I take a drink of coffee. Okay. Looking at figure 414 here, upper left-hand corner, once again, I'll click and you can see the halo. You create a C# source file, right? That file has code in it, okay? And once you're ready, you compile it, okay? Now, you're not compiling it to run on the particular machine that you're on, like if you're using C or C++, although there is .NET version of C++. What you're doing is the compiler is translating the source files into what's called a managed assembly, right? And intermediate language instructions. So you can open up this assembly, okay? It's either going to be an executable, right? It's going to have a file suffix of exe or winx or DLL or .NET module, okay, as is illustrated here, right? That's selected the whole diagram. Up over here, I'm sorry, in this section here, let me see if I can't just select that piece. Okay, right there, right? So you get your source file, however you create it, whatever it contains, then you run it through the compiler. It may depend on one or more modules, as is illustrated down here, right? You can add those and link those in, okay? If you build a DLL, right, then you create another program that depends on that DLL, right? That's what this line down here shows. Oops, once again, this connector here, okay, it shows a connection. You know, you can use that DLL then to create, you know, another program, okay, and then, you know, link it with with the source file that you just created with the compiler, and then create a managed assembly, right? At one point, you're going to get a file that's an executable, and the executable, it has to have a main method, right? And then what happens is when you run that executable, it doesn't run directly on the hardware. It's a managed language in the fact that it runs in a virtual machine, yeah, or the virtual execution system, the VES. Okay, and here's that little piece right there. Okay, and what the VES does is it has just-in-time compilers. Okay, that interpret the instructions, right? Interpret's a bad word. What it does, it goes in there and takes the intermediate language instructions and then compiles them to run on the particular targeted platform. Okay, and then as your program executes, it builds a profile and tries to optimize the code that is being compiled to run on the native machine. Okay, so there's a barrier. There's a barrier between your program and the operating system, right, or the machine, and it is this virtual execution system, okay? And we can go in and disassemble these, okay? And I'll get to that here in a second. All right. So in Figure 415, I have a diagram that shows what it's called the intermediate language disassembler. This is a screenshot, and so what you can do is you can go in once you've created an assembly, a DLL or executable, right? Any managed language assembly, you can go disassemble it. So for learning purposes, it does help, though it's not required, right? To write a short program and then go disassemble it and see how it's put together, and see how these intermediate language instructions are arranged in these managed assemblies. Okay. Okay. So why don't we go ahead and do that? Well, let's see. I'll come back to that in a second. Okay. So we continue on here. I want to talk about the common language infrastructure because as I start writing the source code, I want to draw your attention to some of the facets of the language that you may not be aware of, especially when you're just starting out programming, right? The common language infrastructure, so you pick a language like C#, and most of the time, right, you know, you're going to use C#.net, which is Microsoft product. But that doesn't stop anybody else from making a language, right, that is .NET compliant. Well, I'm going to say it's not .NET compliant. .NET is Microsoft's implementation of the common language infrastructure, okay? So it contains 4 parts, and this is in Figure 4-16, okay, the common language infrastructure architecture. So we have overarching, we have the common language infrastructure, which is, you know, selected in blue here. Now I need to adjust. Let me see if I can adjust everything. I'm going to just decrease the size to like 110% here. Okay, now everything fits in that broadcast window. Okay. So we have the common language infrastructure, the CLI. Okay, within that we have a common language specification. And these are international standards now. So Microsoft's implementation of the CLI is .NET. All right. You can have other languages, other manufacturers create languages that play well. And what holds all these languages together, and this is, I think, the coolest part, is the common type specification, the common type system. All right, the CTS, common type system. And I'll give you a demonstration of exactly what that means. What is the CTS? Essentially, it allows you, as this illustration shows, you can write a program in C#, right? And run it through the C# compiler, okay? And then that results in a managed assembly. Like I said before, it can be an executable, it can be a DLL. Now the difference between an executable and a WinX is an executable has a console associated right with it. A WinX, you know, is a graphical user interface, right? It's a window that has no console showing, no console output, right? A dynamic link library, DLL, or a .NET module, right? A net module is simply a module of code that's intended to be used, you know, to link back to a program that you're doing, that you're running, right? So you can create .NET modules and then use, you know, reference them when you're compiling other bigger pieces, right? So you can have reusable modules. Okay. Now the managed assembly executes on the virtual execution system, like I discussed earlier. Okay, and it's supported by the .NET framework, okay, or the framework of the common language infrastructure, right? All right. And then as the virtual execution system executes, or the VM, it targets the operating system, right? So different manufacturers make VES, or the virtual execution systems, for particular machines. Microsoft, of course, makes the runtime, or I guess you'd call it the .NET runtime, right? The .NET runtime VM for Windows. Okay, there's used to be the Novell or Mono project. I think it's still out there in some form, and you know they had a version that would run on a Mac. Okay, or Linux. And I actually had a student who I was teaching .NET, and they were using the Mono project to complete their projects. Okay, if you're familiar with Java, right, then you know you've got that concept of write once, run anywhere. Okay, and this takes it a little bit further in that you can write a program in C#, J#. I don't even know if that language is still around. It might be Visual Basic.NET and other languages. Okay, that may come out, and I know there are different languages that run that conform to the CLI specification. Okay, the common type system is really, I think, the thing that you really need to take away, right? So you've chosen to program in C#.NET. Let's say that you already know how to program in Visual Basic.NET, and if you don't, that's okay, right? You don't need to know how to do that. But if you do program in Visual Basic.NET, you can write programs in VB.NET, create .NET modules, and you can then link those .NET modules to your C# code. And the reason why you can do this is because they all share the same types in the .NET framework. So let's take a look at what that means. Okay, let's take a look at what that means. I've got Notepad here, so I'm going to create a simple program using system. Okay, let me go ahead and save this file. I usually do that right off the bat. Okay, projects, disassembling code. I'm going to put it here. Simple program. .cs. Don't forget the .cs. Things won't work. Okay, so using system, that's probably all I need right now. So public class, I'm just going to create a class. Simple program. As you know, I like to name my source file the same name as my class, and I like to put one class in one source file, and on rare occasions any other like enumerations that are logically grouped. But even then, I like to keep those in separate source files too. So simple program. Now, in order to get this to run, we need a main method. So public static void capital MAIN, no argument constructors, fine for this example. And I'm just going to say console write line and what program on introductory, what, episode or example of introductory program will be complete without hello world. Just like that. So you save that, then you go to your directory and do a dir, list the contents, and you'll see you have a simple program CS. Now, let's go back. So we've got our source file. And we'll go back up to this process diagram, figure 4-14, excuse me. And we see that, okay, so we have our source file. Now we're going to run it through the compiler. And at this point, there's, we don't have any supporting modules other than the .NET Framework, system namespace. And we don't really worry much about that. So we're going to compile it, and that's going to result in an executable file, at least the way that we compile it, right? So we go CSC, and we can either compile it, since we're only compiling one source file, simple, and you can hit tab to complete that, and that's the only file in that directory. So CSC, simpleprogram.cs, hit return, and if all goes well, you'll just, see the message that it compiled it, and we've got no problem. So clear the screen. Now if we do a directory, we see we have a executable file. Well, now we can go in, we could run that, right? So if we run it, you just type the name, simple program, and it runs. Hello world, okay? Fine and dandy. But now we want to take a look and we want to disassemble that. So we use a program called the Intermediate Language Disassembler, and I've got it opened up over here. Now, a word on how you get this. This is I'm running Windows 10 in this environment. The way that you get the Intermediate Language Disassembler is you can download and install the Visual Studio 2015 at the time of this video, right? Community Edition, and that's the free edition, right? All you do, I think, register with Microsoft, and it doesn't cost you a dime. And it's pretty darn powerful, okay? When you just install it, it doesn't have all the features that you need, right? But what you do is you pull up there's all kinds of different tools. I've got my start, okay, with the desktop tiling, all customized with the development tools that I use frequently, especially for producing these video series. Okay, it includes just a regular command prompt, and then the Visual Studio developer command prompt, the MS Build command prompt, the Windows shell, and then I've got Visual SQL Server 2014, Notepad++, and the IL Disassembler. Now, where would you find this Intermediate Language Disassembler? Okay, after you've installed the Visual Studio, right? If it came with what you're looking for is the Windows SDK for Windows 10, the Windows SDK Software Development Kit. Okay, so I need to take a little side trip here and show you where you find that at. You need to go to My Computer. Excuse me, I'm clicking a bunch of different buttons here. Or this PC, right? So I'm going to drag that icon over here. I've got this on my desktop. This PC. Open up this PC. Go to your C drive. Program Files x86, and look for Microsoft. Oops. Microsoft SDKs. Go down just a little bit. So I've got it highlighted here. Microsoft SDKs. And then go to Windows. And then version 10. Bin. And now I've got two versions, so I just use the latest one. And there you'll see your ILDASM, right? Intermediate Language Disassembler. And I just pin that to the start and to the taskbar down at the bottom. Okay, now let's say that you've installed Visual Studio and it doesn't show up, right? You can't find it on your computer. Well, what you need to do then is go to Control Panel. So I'm going to bring over the Control Panel. You need to finish installing all the different stuff that comes with Visual Studio, which is not installed by default. So Control Panel, go to Programs and Features, scroll down, okay, until you get to Visual Studio. You're looking for Visual Studio, Microsoft Visual Studio, Studio Tools for Applications. We're going to go down a little bit more. I'm sorry, let's see. Microsoft. See, when you sit right next to the computer, sometimes it's hard to actually see what's going on. So Microsoft SQL, Microsoft, oh, there we go. Microsoft Visual Studio Community 2015 with updates. So you right click on it and you'll see change pop up, right? Change. Then you'll see this window checking for the updates. We're not necessarily updating it. What we're doing is we're adding features that weren't originally added to Visual Studio, okay? So you want to modify it once that button comes up. And then if you scroll down through here, right, Common Tools, I've got stuff on here that's not related to C# per se, but I go down here and I'm going to put Common Tools and Software Development Kits, and then down at the bottom I got Apache Ant, and then down here there's Common Tools. So scroll down even farther. You want to make sure that's all installed. Okay, so check anything in here, and then the other place to check, I'm going to go ahead and quit that, is go all the way down to Microsoft Windows Software Development Kit. Okay, and there's two different versions here. You can click on either one. Okay, and then change, and make sure make sure change is selected next, and then select the Windows Software Development Kit, Windows App Certification Kit, .NET Framework, anything that you think is missing. Okay, and make the change there. I'm going to do this. Say no. Yes, I'm going to cancel that change. Close that window. And then I'm going to actually click on this next version up here and say change. And go next. Okay. Anyway, I selected this one right here, .NET Framework 4.6 Software Development Kit. Okay, so you might want to go check those if you don't find it after you've installed Visual Studio, okay, and the .NET Framework. Okay, enough about that. So once you've got your disassembler up and running, what you do is if you want to disassemble a file, you just click File, Open, and then navigate. In this case, I'm going to my Desktop Projects folder, Disassembling Code, and I'm going to click on Simple Program and open it up. And then what you'll see here is, really what a managed assembly is. It's XML. There's there's XML in it, right? It's got metadata. Okay, so we have a simple program, which is our class. We have a constructor, which CTOR stands for, and we have a main method. So if we double click on the main method, we'll see the contents of the main method and the intermediate language instructions that are there. So, and what you want to do is if this looks like Chinese and you're not used to this type of stuff, right, you can go out there on the internet and look for, in this case I've used the Microsoft Edge, and I went to Wikipedia. There's a plug for Wikipedia. And of course, they've got the reference on Microsoft's MSDN website as well, right? So, list of CLI instructions. Okay. You can scroll down here and take a look at ones that you don't understand, but for the most part. So, we have an entry point. The size of our code is 13. bytes, I guess. Okay, the max stack is 8 bytes, or 8 words. So let's see here. We have a no-op instruction, and then we have a load string, okay, and it loads the string hello world, okay, into probably this address, right? And then we have a call, okay? So what it does, it's going to call mscorelib, which is coming from the mscorelib DLL, the system.console and write line string. Okay, so it loads the string, and then it calls the write line method, which is what we're doing. Then there's another no-op, and then it returns from the main method. And so really that's all that main method does, right? So the the disassembler is a helpful tool to go in and explore. And so this shows that even though I didn't specifically create a constructor, it shows that the compiler will provide one for you automatically. Okay. And so that's practically all I wanted to talk about in this short video was, when you're starting off with C#, what is it that you're actually creating? You're creating a managed assembly modules, right, that execute on a virtual machine. And essentially these intermediate language instructions are loaded up into the virtual machine when you launch the program, and then as they start executing, they're translated into machine code that targets the particular type of computer that you're running, and the operating system. Okay, and there's always that safety layer, right, because you're running these programs like C#, right, in a managed environment. Okay, if you can combine, C# code, which is managed code, with code like written natively in C++ or C or another language. Okay, and that would be like a hybrid program. Programming languages that are not managed, in other words, they're not part of the .NET framework, are called unmanaged languages. All right, and unmanaged language allows you to go in and reference pointers, okay, and change what pointers point to, and let you diddle with the code in ways that your managed language running in the virtual execution system or the .NET runtime do not allow you to do. So there's an increase in safety when you're using managed languages, okay, versus unmanaged languages. Alrighty, and some would say there's a performance increase, although performance isn't bad, right, with these modern managed languages. Okay, so that's it. Thank you very much for listening to this lecture, and happy programming. If you have any questions or comments or requests for videos, hit me up at rick@pulpfreepress.com. And once again, this information can be found in my book, C# for Artists, 2nd edition. And once again, I'll give you that shameless plug for that book. Anyway, happy programming.